Hello everyone. Today we are looking at differentiation from first principles, and let us consider a curve, our basic curve, a simple one, y being equal to x squared, and that this curve has a point P, which point P has coordinates x and y. So our curve will be like this. We have our y-axis, and then the x-axis. So drawing the curve, it passes through the origin, something like that. It is not that neat, but it will work for us. So if we consider some 2 points, first of all, the point P we talked about at the beginning, to be at that point, and a point, say point A. This one be point P, and this one be point A. So assuming point A is very close to point P, we shall be having a line joining point A to point P. I'm trying to draw a straight line, and we form a triangle here, which we can use to find the gradient of the point of the line AP. Now, this will be this horizontal line will be having a small change in x, since we said A is very close to P, and this vertical line, it will be having a small change in y. So that gives us the coordinate of A to be x plus a small change in x, and y plus a small change in y. So that is the coordinate of A, and we also have the coordinate of P here. So using our gradient, we know that to find the gradient of a line, we have to use change in y over change in x. But we need to use better coordinates, which are in terms of x. So P can also be written as, since our curve, it is having this as the equation, so the coordinate of P can also be written as x and x squared. X for the x value and x squared for the y value. Then the coordinate of A can be written as x plus the small change in x, and our x plus the small change in x, all of it squared in bracket. So gradient of PA, the code PA, is given by the change in y2 minus y1 over the change in x, x2 minus x1. So here we shall use this as our x1 and y1. This one will be our x2 and y2. So we are going to use these as our coordinates in this expression. Let's go to the next page. So our gradient, allow me to use the abbreviation grad, is equal to the y2. Remember our y2? Our y2 is x plus the small change in x squared. It is x plus small change in x squared, then minus y1, which is x squared, over x2 is x plus small change in x, and then minus x. That is it. So we expand this, expand that, it will give us x squared plus 2x small change in x, and then plus the small change in x, all of it squared. You can even put it in brackets, and then minus x squared all over x plus small change in x minus x. So in this case, you can see some values cancelling. This x squared is cancelling with that, and this x cancels with that, and remain with 2x plus small change in x, and then, excuse me, it is 2x, it is 2x small change in x, and then plus small change in x squared over small change in x, and this small change in x divides that and remain with only 2x, and also it reduces this and remain with only 2x plus small change in x. So this one should have been the gradient of the line AP or PA, grad of our chord PA is equal to 2x plus small change in x. But remember, we mentioned that A is very close to this. So if the small change in x tends to 0, you write it like small change in x tending to 0. You see this small change in x tending to 0. Our gradient will be moving very close to the point P. And we shall say that now that one is the gradient of the curve at point P. Or we can call it the gradient of the tangent. So if this one tends to that, to 0, we shall be having the gradient at P being equal to 2x. So this is what we refer to as differentiating from first principles, if we get this. Then in our next video, we shall learn how to differentiate using the formula. Thank you.